Ever wondered how pilots know exactly how fast they're flying through the air? It's not like cars. There's no GPS speed or speed gun in the sky. Instead, aircraft use a smart little instrument called the Airspeed Indicator. In this video, we'll see how it works, what it measures, and why it's one of the most important instruments on any airplane. The Airspeed Indicator, or ASI, is one of the 6 main flight instruments found in an aircraft cockpit. It shows the pilot the aircraft's speed relative to the air around it. It works using pressure from the air that flows into devices called the pitot tube and static port. Here's how it works. As the aircraft moves through the air, the pitot tube collects the dynamic pressure. That's the pressure caused by air flowing into it. Meanwhile, another small opening called the static port measures the static or still air pressure outside the aircraft. Inside the airspeed indicator, these two pressures are compared. The difference between the total pressure from the pitot tube and the static pressure from the static port gives the dynamic pressure. This dynamic pressure moves a diaphragm inside the instrument, which in turn moves the needle on the dial, showing your airspeed. Those color arcs on the airspeed indicator aren't just for looks. They show safe speed ranges for the aircraft. White arc. This is the flap operating range. You can safely extend flaps here. It starts at VSO, the stall speed in landing configuration, flaps down. It ends at VFE, the maximum flap extension speed. Green arc. This is the normal operating range. The aircraft flies comfortably and safely here. It starts at VS1, the stall speed in a clean configuration, flaps up. It ends at VNO, the maximum structural cruising speed. Yellow arc. This is the caution range. Only use it in smooth air and with care. It extends from VNO up to the red line. Red line. That's VNE, the never exceed speed. Go beyond it and you risk structural damage to the aircraft. But the airspeed indicator isn't perfect. If the pitot tube or static port gets blocked by ice, dust, or insects, it can give false readings. That's why aircraft have pitot heat systems, to prevent freezing, and pilots always check these instruments before flight. Airspeed is critical in every phase of flight, from takeoff to landing. Too slow, and you risk a stall. Too fast, and you could overstress the structure. That's why pilots constantly monitor the airspeed indicator. It's truly their speed sense in the sky. If you enjoyed learning about it, hit like, subscribe, and check out our previous video on the pitot tube and static port.